Good morning, friends. Today we are going to discuss about a very important topic that is India's semiconductor mission, and we will be starting with mission one to mission two and their comparison and its importance to India as far as the policy is concerned. Okay, and uh, and later we are going to have a a view on its India's potential as far as India is concerned, and what are its gaps to achieve this mission right now. So let us start and welcome to our BTA Beyond the Attempt, and we are going to have at least one topic every day on UPPSC and APPSC syllabus. Let us start with the lesson. So, when we talk about Mission 1, and it was actually started in 2021 in order to reduce our dependence on electronics, automobile, telecom, defense sectors. As we know, we are one of the major markets of electronics. Okay, electronics. So obviously these electronics are being supported by the very core of this electronics is the semiconductors, right? So in order to reduce that dependence, we have identified a policy in terms of semiconductor mission 1.0. So being a big consumer market, India, everybody is interested in uh, uh, everybody is interested in the investing, so that they will have a ready market in our country. So having that background, so we have made a policy to attract a lot of investments from around the globe. So the mission 1.0 is being designed in a way that it will have all the aspects, so that we will have our indigenous or Atmanirbhar units in our country to support and reduce our dependence on semiconductors. So, on part of that, initially semiconductor fab scheme. So the semiconductors fab means these are the fabrication facilities, fabrication units in our country. What they will fabricate is they will fabricate the required for chips required for the electronics used in our various sectors like space, automobiles. Okay, space, automobiles, electronics, IoTs, even the present technologies like 5G, IoTs, okay, artificial intelligence, robotics. So these will have the broad spectrum of uses. So we have announced a 50% fiscal support on capex, the capital expenditure. Okay, and display units like AMOLED and LCs fabrication units have been given incentivized, and in various incentive schemes were given for ATMP assembly, testing, marking, and packaging. And we will go in detail what is that ATMP and OICT. OICT means outsourcing, assembly, and testing. So, on part of that, these assembly, testing, marking, packaging, OSIT schemes will have these things. Okay, so they will use the silicon carbide and gallium nitrate sensors. Okay, they will use it in their assemblies, and design linked scheme has been given a support. if they design in India, and they will give an incentive. They will be given incentive if they and if they design for the design for high technology components. Okay, they will be given extra incentives like that. And they also given a target of 85 target to make 85,000 plus skilled engineers over 5 years. This also been has been envisaged in 1.0. Okay, as far as the data is concerned, so the status of 1.0 1.0 is concerned, so initial outlay has been given as 76,000 crores. Okay, and under it around 12 fabrication package projects, 24 chip design projects, and across 6 states. What are they? Gujarat, the very first project has been started in Gujarat, and later Assam, Odisha, Punjab, and now it is in AP. Okay, the cumulative investment attracted out of this outlay of 76,000 crore is 1.64 lakh crore. The very first project is Micron at Sanand, and later at Keynes CG Semiconductor facilities. So actually, I think Keynes. I just have to see Keynes where it is located. But Sanad is in Gujarat. One more Tata facility is there. Tata facility is also there for manufacturing or fabrication of semiconductors. Okay, and EDA tools have been also given access in order to improve the ecosystem of this. So EDA means electronic design and automation. Okay, EDA. Okay, this is the EDA means electronic design automation. Actually, this has been supported by CDAC. CDAC of Center for Advanced Computing. So actually, this is the software platform where all the tools required for the designing of these semiconductors. So support for software support, and software tools for designing, like like CAD, like CAD softwares, and other required softwares will be there, so that the investors or entrepreneurs or MSMEs will come here and use this facility, so that they will not have to install a facility or invest in these kind of things. This will act as a supporting ecosystem for these companies. Okay, so fine. Then what was the need to why the 2.0 have been envisaged when 1.0 is there? Thing is that we have come to know after 5 years of experience in 2026 that the approval process has been envisaged was very slow. So there is a lot of red tapeism. Okay, the first point. Second one is many companies has actually come to India to get the benefit of subsidies, not for the sake of investment, manufacture here and export from here. Okay, so, and third one is and what was envisaged earlier, it was outdated. Actually in 1.0 it was envisaged out of 28 nanometers to 90 nanometers range of chipset was envisaged, and that is actually it is outdated right now. So because of the technology advancement, 5G, 6G, okay, AI, IoT, okay, all of the technologies. Hmm? And also India doesn't have much of the facilities required for the various stages of semiconductor making, right? Semiconductor, actually we already know semiconductor will be developed through various stages. See, first silicon will be liquefied, so it will be solidified into ingots. First is liquid silicon will be there. They will be solidified into ingots. Ingots will be converted into wafers, small layered silicon. Okay, this layered silicon is nothing but a raw material. It doesn't have any conductivity or electrical properties. So what they will do, they will dope. Okay, they will dope these silicon layers so that it will be conductive. You know what is doping? I think you already knew this. Okay, doping means they will induce impurities phosphorus and gallium. These were the basics. So once they will be doped, it will be converted as a conducting material by doping. Okay, once the doping is done, and the later process will be done. Once the doping is done, on that photo masking will be done. Photo masking means okay, there will be transparent and intransparent layers will be there. Layers, so see, this is the layer of silicon, plus doping will be done. So this will be one layer. This is the electrically conductive material. On this one more layer, this is a transparent. On this layer there will be circuitry. Okay, once this circuit will be there, this will be injected with UV light, photo UV light. So once the UV light will be there, whatever the UV sensitive or light sensitive things will be there, that will be solidify that will be removed, and the remaining part of circuit will be there etching means that see, this whatever this layer on that silicon layer, circuit will be projected onto that wafer. So this is where the transition this is where this transitions transistors, different types of transistors, p-n junction diodes on this silicon will be made. So once they are cutting into different parts, that will be the die. Okay, different dies, dies. So we have seen in semiconductors, see, this is one more chip will be there. This is the die actually. On this different kinds of terminals will be connected, right? So this terminal connection is nothing but middle part is the die. When this how this die will be made? By cutting the silicon fiber. That silicon fabricated silicon will be there on this the circuit will be there. Okay, the circuit is electrically conductive. After doping it will be transformed into the transistors, and those transistors will be connected with the different pins. So these pins will be connected with other pins. So how this is called as a transistor. So the very important step is, once this die is there, which is having a circuit, die is having a circuit plus doping plus electrically connecting aluminum or copper will be there, which will have the which will provide the conductivity along with the paths. Okay. So and later on there will be they will give the connection, which is called as what? Chip. So this chip is very sensitive. So in order to protect it, there will be a ultra. Okay, they cover this layer with which can cover this layer with different materials. Okay, and chemicals also will be used. So they will cover this so that it will be protected from the sunlight, dust, and the water and all. Okay, this is how the chips will be made. These chips will be used in a different circuitry. Okay. This is how, that is the problem. So I just forget one thing. And before the fibers, there will be a design thing. So for design, we don't have kind of advanced facilities we need it. So design means what? So designs should be made, designs, and later on IPs, designs should be given an IP. Okay, a design should be given an IP. So what is IP? Intellectual property. So intellectual property rights will be given, and they should be protected through legal framework, so that investor will come. Legal framework should be there, so that investor will come confidently and invest. Okay, this is how the ecosystem is developed. And one more thing is that not only this, in 2.0 we have a target of by 2 nanometers by 2035, 2 nanometers chip by 2035, 3 nanometers by 2032. Okay, earlier we have 28 nanometers to 90 nanometers target. Now this target has been changed in order to meet the advanced technology demands. Okay, and if we talk about investment outlay of 2.0 is 1.26 lakh crore. Earlier we have 76,000 crore. Now it is almost double to 1.26 lakh crore. Okay, initially in budget 1,000 crore has been given. Okay, and also one more important is a full stack approach. Right, full stack approach has been given. Like full stack means right from the raw materials to the R&D, advanced packaging, R&D, advanced packaging, advanced chemicals. Okay, different specialty chemicals, raw materials requirements, everything has been supported with the advanced chemicals. So this is how we have given an ecosystem support for the in 2.0. Okay, and also earlier we have a supporting mechanism of in terms of incentives, but now we have a design linked incentives in line with in terms of pari-passu. Pari-passu means proportional incentives will be given. Pari-passu. So pari-passu means, for example, I have invested in a design of value around 2 million. Okay, so proportionally we will release the incentive. If it is 10 million, proportionally we will release the incentive, like that. Okay, and also skill support. Various universities have been identified. It is almost I think uh, 320 institutions have been identified to improve the manpower, and the industrial academy collaboration also been encouraged to have the skilled manpower in order to meet the investment mechanism, investment um, uh, about to come into our country. Okay. And yeah, I just also forgot to mention that there is a lithography technology which is very costlier and which is very advanced. So that kind of things we were not have earlier, and we used to lithography, photolithography means photolithography by using lasers. Okay, we will mark the circuit. We will uh, we will mark the circuit on fabricated silicon wafers. This is the very initial step after the design, through which we are going to have the final design of chip making. So this is all about 2.0. So if we talk about the vision, okay, if we talk about the vision, the main vision is to reduce the imports, reduction of the import, okay, improve the exports from our country, so that we know reduction of the imports and improvement of the exports, what kind of trade balance and other BOP um, uh, other BOP support will be there for our country. That is the one thing. And third one is to have the strategic resilience, okay, and to have um, supply chain okay, supply chain resilience, okay, strategic support and supply chain. Strategic support means semiconductors will be acting as a backbone of our emerging technologies like IoTs, AI, cloud technology, okay, robotics, okay, and all other quantum computing, space technologies, defense, okay, automobile. All these will require the advanced semiconductors of capacities 2 nanometers and 3 nanometers level, that will be supported by this thing, strategic mission. This is one of the strategic missions of our country. And supply chain resilience means as we know, recent wars and COVID have disrupted our supply chains of critical raw materials from China, okay, and critical raw materials from Chile, Peru, like that, okay. So when we have our own raw materials at our country, in our country, so what were the raw materials? Raw materials require this mission are importantly specialty chemicals, okay, and very pure gas, very clean gas, okay, and we need very high clean water for cleaning, okay, and uninterrupted quality power supply, okay, and other core raw materials like silicon, okay, silicon we also used to import, because all these things I will tell. Specialty chemicals we don't have, and we used to import from other countries like China, Taiwan, US, even Chile in China, and Peru, and and straight away we used to import many materials, and we used to assemble here. That also should not be there. And power supply, I just wanted to tell you the one example, like even 1 microsecond of power interruption will damage a batch of 2 to 3 crore worth chip making. Okay, so that much importance it will have the quality of the power supply. And what about water? Yeah, water should be very clean. Even one single impurity of water out of about 1 million liters of even one molecule out of 1 million liters of the water will damage the whole process. So that also should not be there. And silicon, we have a surplus silicon in our country, but it is not actually um completely useful, because it will have some kind of impurities. We may have to use advanced technology, and which is very costly. So we are actually importing very clean silicon from other countries. So this raw material security or raw material things will be established here, so that and they will be incentivized in various mechanisms. Okay, and also one more thing is that state support. State support, like for investment and technology import, it will be given by the private partners. And infrastructure and other critical support and procedural thing administration will be taken by governments, particularly state governments at that point, like land acquisition. Okay, like environmental things. All these essential steps will be taken care by the state governments. That is how this policy has been taken up. Okay, so when we going through all these things, and I have given the different steps, and how actually semiconductor process will be started, right from the circuitry design and photo mask making, I have said already. So and lithography. Okay, how fibers, different fibers, wafers of the silicon will be done, and how they will be oxidized so that it will be protected from the other impurities. Okay, how they, and later how they will be circuit will be etched on it, etched on it. Okay, like that. So all these things are very important. Okay, and where we are lacking in the circuitry design, litho, up to this part. These are the very advanced, up to photoresist coating and lithography also. We don't have this technology. Okay, lithography, it's a laser supported designs. So these requires a lot of investments, and also the clean raw materials also requires a lot of investments. That is the reason why we have changed the policy right from the 1.0 to 2.0. Okay, and later, if we talk about India's potentials, what were the potentials for the India, so that we can attract the investment, means large domestic electronics market. We have almost 250 billion electronics production ecosystem we have over the 5 years. Okay, talent pool, we have lot of talent pool, like VLSI engineers are there. Okay, China plus one, actually country is looking for other global chip makers. China is one of the topmost chip makers. So the world of many countries is looking for one more country, so that we will have a supply chain supplier. Okay, we can stand as a important supplier in the supply chain management. And And one more thing, we have already increased outlay from 76,000 crore to 1.25 lakh crore. This is one of the important thing. Without financial support, nobody will come to our country to establish their units of this chip design making. And one more thing is that DLA supported fabless startups. Almost we have 50 right now, because it has been already encouraged and energized by the 1.0 mission. Okay. And ever growing market for AI, IoT and EV applications is there in our country. Okay, because all these sectors are increasing. uh, Already Micron, Keynes, CG, Semis have already in February 2006 have designed and out for the commercial production. Okay. And what was the lacunas, or the which lacunas we just have to identify? That is the one more step. So right now we are import dependent for advanced technology like lithography. I have already said it. Okay. And already said that it will take a lot of time to design 3 nanometers to 2 nanometers uh, uh, this thing. Actually we don't have that much maturity, but critical experts are saying that it will take around 15 more years to mature to reach this capacity. So this vision is 2032 to 2035 may not be achieved in that timeline. So we have also infrastructure bottlenecks like power supply. The quality power supply is the main problem, and the industrial water supply is the one of those main problems. Logistic supplies are there, logistic supply problems are there, like that. And a talent mismatch. Right now we don't have uh, uh, we have chip design makers like VLSI engineers, but we don't have specialty fab process engineers and the technicians which are experienced in high volume manufacturing. That is the one more important things. Like see, various steps requires various types of engineers. So we need to map that manpower to the exact need of those chip making design. And the execution culture is very slow, and foreign technology partners dependency is very high. So that also should be there. Maybe I think the autonomy thing is involved here. So it may take much more time as anticipated. Okay. And genuine indigenous technology is still emerging. It is not actually well established. Okay. And in order to attract investment also, India still has to demonstrate that we are the big players in as compared to China. So this is all about that. And I have given advantages of 1 to 2.0 approach. Okay. And what were the, so please go through it. Okay. And see, and we have already given the full stack of framing. Full stack means right from the design to the stage of packaging. That is the final stage. Okay. And already ready market is there. And one more thing is the PLI scheme is for electronics and semiconductors is there. Okay. And they will give the extraordinary support for the fast approvals. Okay. Challenges are executions in execution stage, like um, actually, as far as the policy announcements will be faster in our country as comparative to actual construction. And the land acquisition delays will be there obviously in our state, because states have been given the responsibility for land acquisitions things and infrastructure support. And there will be a center state coordination. All these things will be involved later to realize this thing. Okay. See, I have already said it, 15 to 20 years maturity. it will take in order to meet this thing, meet this target. Okay, and geopolitics are playing important role, because still we are actually um, actually depending on the advanced nations for cutting edge tools. That is also one more imperative. Okay, all these things are there. So what to do is, okay, we need to sustain this funding and the policy across the all the across the election cycles. Okay, the once the government once the one government come, and it will change it, and the other government will change it, like that. So this is not feasible, though political stability should be there. Okay, and industry academia should be supported. Apprenticeship should be given, like in already we have given, like setu policy for entrepreneurships, apprenticeship supports. Okay, ITIs will be incentivized by giving them apprenticeship, like they will be given skills and some kind of amount for monthly stipend kind of thing, already established in our country. So like that, many policies should come as far as the semiconductors is concerned. Okay, uh, like this. These are all the areas we need to, like, see. We have a demand of electronics EVs. Okay, so this is one more important step, and further we need to encourage them in all these sectors, and we need to market like that. We have already extraordinary domestic demand for all these sectors, like that. So we need to reach the global partners. So there are many aspects, because it is a overarching policy. So this is all about this thing, friends. So you can have go through this, you can pause and go through the each and every this thing policy, right? It is actually covered the whole aspects of semiconductor mission. Okay, thank you.